As we start our study in trigonometry, we're going to be looking at angles, how we label them, how we talk about them, how we measure them, and then start building this idea of the unit circle. So an angle is measured in standard position, which means that the vertex is at the origin and one ray is on the positive x-axis. We call this the initial side, so initial where we're starting. The other ray is called the terminal side, so terminal as an ending, where is it stopping. So on these two pictures, we show a positive rotation to the left. We see that we have the initial side in blue on the x-axis, and then it rotates around there to the terminal side in red. Same thing for the negative rotation, other than it's in the fourth quadrant. So when we've used angles before, we've used them in terms of geometry and right triangles with your trigonometry studies so far. So you've never dealt with negative angles. We can measure negative angles when we're thinking about rotating around the origin. So the angle is formed when we rotate that terminal side. If the terminal side is rotated counterclockwise, that's when we have that positive angle measure that we saw at the beginning. You will measure angles in the counterclockwise direction unless you're specifically told that it's a negative angle or that they want you to measure it in the clockwise direction. Because we are on this coordinate plane, we can actually measure angles more than 360 degrees. So if you think about an analog clock where that minute hand is moving constantly and it just keeps going around and around, our angles do the same thing. So we actually can have angles that are greater than 360 degrees by completing multiple rotations around the axis. So when we're drawing angles in standard position, we want to think about these quadrants as multiples of 90. So here at the top would be our 90-degree angle because we started here at 0. We haven't moved anywhere if I start with my initial side at 0. Halfway around is 180 degrees. 3/4 of the way would be 270. And then a full rotation, a full circle, is at 360 degrees. So a 320-degree angle measured in the standard position would be down here in the fourth quadrant, and we're just going to kind of estimate right now, but that would be about 320 degrees. To measure negative 110 degrees, again, that means we're now moving in the clockwise direction. So if I started here at 0, this angle would be negative 90. This would be negative 180. And then negative 270. So a negative 110-degree angle is going to be slightly past 90, and we would have moved this direction to go negative 110 degrees. For example C, 990 degrees, so well past that 360-degree mark. So if we think about multiples, we would start with 360 as one rotation. 720 would give us 2 rotations. 1080 would be 3 full rotations around the axis. So we're stopping somewhere between 2 and 3 rotations. So we can go ahead and show here that with my initial side, I'm going to rotate once and twice. And then we need to figure out how many more degrees we need to go. So to do that, let's go ahead and subtract the 720 degrees that we've already rotated. And that means we have 270 more degrees to go. So this would be 90, 180, 270. So our terminal side would end up down here. And we would have rotated 990 degrees. So looking at these pictures, if we didn't have these directions here that told us, which way we were moving and what the angle looked like, we really wouldn't know just by looking how that angle was measured because they look the same. Our 990-degree angle looks the same as a 270-degree angle if I had just rotated that way in a standard position. This is what we refer to as coterminal angles. So co, with, terminal, ending, angles. So they're together where they end. So in standard position, two angles would be coterminal if they're stopping at the same place. So 120 degrees measured counterclockwise, so this direction is going to look the same as 240 measured clockwise. And I don't have any idea about which way that was measured without seeing that directional arrow and having some information that them showing me the 120 and the negative 240. So because we can continually rotate around and around, there's infinitely many coterminal angles. So if you were asked to find coterminal angles, there's technically infinite correct answers. The easiest way to find coterminal angles is simply to add and subtract multiples of 360. So if we were asked to find one positive and one negative for each of these angles, we're simply going to think about adding and subtracting to get us to that rotation back around. So 65 degrees would be in that first quadrant. Now I can rotate another 360 degrees and add those two numbers together, which is 425 degrees. So 65 degrees and 425 degrees look the exact same other than the additional rotation. To find the negative, we can subtract 360, and I only have to do that one time to get into negative values. Sometimes you have to add or subtract more than one rotation, but you want to keep doing that until you meet the criteria, and you'll always be told which type of number you want to find. So again, a negative 295 degree angle is going to look the same plotted and drawn out as the 65 degree angle. So take a minute and complete questions 2 and 3. Pause the video, and then when you're done, unpause the video and check your answer with mine. So hopefully for 88 degrees, you have a positive coterminal at 448, a negative at 272. For negative 320 degrees, your positive coterminal could be 40, and negative 320 minus 360 would give you negative 680. And again, there's infinite answers, but typically you're just going to want to keep adding and subtracting 360 until you hit either the positive or negative value. So as well as measuring angles in degrees, we can measure them in radians. So a radian is an angle that is at the center of the circle, so it's a central angle, and the arc that it opens up to is also equal in length to the radius. So we can actually fit 6.28 of these radian angles inside of that circle. And if we divide that by 2, we would get 3.14. And hopefully 3.14 jumps out to you as pi. So we start to think about when we're measuring things in terms of pi, that's going to be half of the circle. So in half of the circle, or in 180 degrees, we would have 3.14 of those triangles. And we would say we had pi radians there. So when we convert between degrees and radians, we use this idea of pi to help us do that. And again, we said that 180 degrees is the same as pi radians. So if we're going to convert from radians to degrees, we're going to multiply by 180 over pi. And to go from degrees to radians, we're going to multiply by pi over 180. So because those two things are equivalent, we can set them up in the fraction that way. And then we think about our unit conversions, that if I were to go from 120 degrees to something in radians, I would need these units for degrees to cancel. So top and bottom. And then we're going to simplify this fraction. So we would have 120 pi over 180. We want that to be in the most simplified fraction. This is going to be a nice fraction. So we can simplify. 6 goes into 12 2 times. It goes into 18 3 times. So 120 degrees is 2 pi over 3 radians. Sometimes they're not as nice as those fractions. That one is actually one that we're going to be looking at on our unit circle when we start to build that. So if it's not as nice of a number, then you can simplify that fraction as much as it will go, or we could actually take that and make it a decimal, which is not necessarily the most preferred answer mathematically because it's not precise once we start, thinking about converting pi to a decimal, but it gives us what we need. Same thing for 85. So I want you to pause the video, convert 85 degrees, and then check your answer, or negative 85 degrees and check your answer. So when I divided negative 85 by 180, I got about negative 0.4722. So I just rounded that to negative 0.5, and then we would still multiply that by pi. So when you are giving your angles in terms of radians, we typically leave them in terms of pi. We don't multiply that out. All right, so to convert from radians to degrees, and again, I know this is in radians because it has pi, and I'm going to want to cancel that unit of pi. So that's how I remember that that one goes in the denominator. So pi cancels top and bottom. So we're going to take and multiply negative 3 times 180, and then divide that by 4. So that's going to be negative 135 degrees. And again, that's because this is degrees here. The other thing that you can do for these, rather than having to remember the fraction, you can remember that pi and 180 are equivalent. We could substitute 180 degrees here, and then just simplify that. And again, this is not going to be a nice even number, and that's okay. I got about 142.1. All right, pause the video, work number 6, and then come back and check your answer. So regardless of the method that you chose to use for number 6, hopefully you got the answer 154.3 degrees. So from here, we're going to start building that unit circle. We do want to be comfortable with angles, how they're measured, what they look like, those rotations around the unit or around the axis. But we specifically want to remember that relationship that 180 degrees is equivalent to pi radians.